Let's try another example where we find intervals of increase and decrease and local maxima and minima using the first derivative test. Alright, so we've got g of x equals x over 16 plus 1 over x. We look for discontinuities. I hope the x in the denominator leaps right out at you, and we've got x equals 0 is a discontinuity. Alright, so we found our discontinuity. Now we need to differentiate. So I'm going to rewrite the function as 1/16 x plus x to the minus 1. And then that tells us that the derivative is 1/16. That should be a plus. Minus x to the minus 2. Or 1 over 16 minus 1 over x squared. Now, in looking for critical numbers, of course, we want to figure out places where the derivative is either undefined or equal to 0. It is undefined at 0, but remember that's a discontinuity for the function, and so that's not really a critical number. So what we need to do is now set the set the derivative equal to 0. And let's rewrite it this way. And now we can cross multiply, and that tells us that x squared equals 16, or x equals plus or minus 4. So what we need to do is decide which intervals we're going to be working with. So at 0 we've got a discontinuity. At 4 and at -4 we've got critical numbers. So we've got 4 intervals from negative infinity to -4, -4 to 0, 0 to 4, and 4 to infinity. There are our 4 intervals. We need a test number from each interval. How about -5, -1, +1, and +5? So if we substitute in -5 for x, we're going to get 1/16 minus 1/25. That should be positive. And we'll get the same result when x equals +5. And then if we substitute in -1, we're going to get 1 over 16 minus 1. That'll be negative, and again we'll get the same result for +1. So that tells us that the original function is going to be increasing, decreasing, decreasing, and increasing. So it's increasing on this interval, but let's go ahead and extend that out to include the endpoint -4, and also the interval from 4 to infinity, including the endpoint. It's decreasing on these two intervals. We can include the -4, but we cannot include the 0. nor can we include the 0 in the other interval, and we can include the positive 4. We cannot include the 0 because, remember, the function is not defined at 0. Alright, so what about relative extrema? Well, the function is increasing until it reaches 4, and then it decreases. So it's got a relative maximum at the point where x equals -4. And I think it's got a relative minimum at this other critical number. Yes, the function is decreasing and then increasing. So we've got a relative minimum at x equals +4. Now to determine the y-coordinates, all we have to do is just substitute 4 and -4 into the original function. So if we substitute in the 4, we'll get 4 over 16 is 1/4 plus 1/4. 1/4 plus 1/4 is 2/4, or 1/2. And if we substitute in a -4, we'll get a -1/2.